This is a recap on a little factoring that we have started in Algebra 1. And it's possible that some of you have already done some work with this, and it might be new to many of you. Okay, so, or at least a few of you. But use it as a review if you are already kind of feeling comfortable with these concepts, and if you just feel like you need a little more practice, then that is a great reason to watch this video. Okay, so we have been working with polynomials, and we've been working specifically with adding, subtracting, multiplying polynomials. And somebody asked about dividing. Well, we actually, and if you want to be on page 41 for this exercise, that would be a great place to start. We actually call that factoring when we're kind of pulling apart pieces that we see in common from different terms. And we're going to start with this idea of the greatest common factor. Okay, and so when we think about a greatest common factor, and factoring, it can be a little daunting, but don't be scared. We're going to get to it. We're going to get lots of practice, and you guys will end up being able to factor throughout your mathematics career. All right, it's one of those super important skills. So greatest common factor, if we just think about a couple of numbers, like let's say 27 and 18. Okay, and if we're thinking about the biggest number that can be divided out of both of these, that would be the greatest common factor. So typically, you guys have done work with maybe listing factors, right? 1 and 27, not even, so 3 and 9. I think those are the only factors of 27. For 18, 1 and 18, 2 and 9, 3 and 6, right? So what we don't want to do is we don't want to say the greatest common factor is 3, right? It is a common factor, but it's not the greatest common factor. It's not the biggest number we could divide out. That would be 9. So as we think about greatest common factors, we're going to be not only pulling factors out of integers like you see here, but we're also going to be looking at, for example, the greatest common factor between, let's say, x cubed and x squared. Okay, well, x cubed has x times x times x. X squared has x times x. So the biggest common factor that can be pulled out of both is the x squared, because they at least both have or contain x squared times 1, right? Or in this case, x squared times x times 1. So that's the greatest common factor for those variables. So now we're going to put these two ideas together, and we're going to practice a little bit with just dividing out what you think is the greatest common factor. So we're going to start with this one right here, number 2, from page 41. And we're going to look at each of these terms and decide if there's anything that is a common multiple between them. And it looks like 4 would work, right? Because 4 times 3 is 12, and 4 times 2 is 8. And then, oh, wait a minute. That 4 is not going to work with the 10, right? I can't divide 10 by 4 evenly. Okay, so it can't be 4. 4 cannot be the greatest common factor. What else? Well, they're all even. Maybe 2 is the greatest common factor. Okay, they all look like they're divisible by 2. That looks good. We could divide each of those pieces by 2 and divide out a greatest common factor. What about x's? Do all of them have at least one x? Oh, this one has an x cubed. That would be fun to be able to factor out an x cubed, but that one does not. That one's too small. And this doesn't have any x values at all. So what you're going to do then is you're going to kind of identify what that greatest common factor is that you could actually divide out of each term. And you are going to write it down. And then what goes in the parentheses is the value that is left after you divide out that common term. All right, so the 2 is going to go outside the parentheses. In the parentheses, we get 6x cubed minus 5x squared. And I'm running out of room over here. Let's get a little extra room, and minus 4. Okay, now, don't forget that you can always check to see if you factored correctly by multiplying back through. So if you did 2 times 6x cubed, that would be, oh yeah, that would be my 12x cubed right here. Perfect. If I did 2 times my minus 5x squared, that would be my minus 10x squared. That's looking good so far. If I do 2 times my negative 4, that should be negative 8. Oh yeah, there it is right there. So you have factored correctly. Okay, let's try this next one. Something that is common to each of these terms. Oh, look at those 7s. A 7 there, a 7 there, a 7 there. So I'm going to divide a 7 out of each of those. Can I divide any number of this variable p here? There are 2 of them there, 3 of them here, 4 of them here. So it looks like I could at least divide a p squared out of each, right? So this is our common denominator, which means I'm going to make some more room for myself over here. Sorry about the momentary pause while we create some more room. So my 7p squared goes on the outside of my parentheses, and on the inside of my parentheses is what I get when I divide. So 7p squared divided by 7p squared is just going to be 1. Very important to have that placeholder. Anything divided by itself, it's not 0. A number divided by itself is 1. Okay, so you have to remember to have that placeholder. Let's see, p cubed divided by p squared is going to leave us with 1p, and then 7p to the 4th, the 7's cancel. 4 of the letter p on the top, 2 on the bottom, which means I should have p squared as my final term. Okay, so if you want to try 6 and 8 real quick, I'll just pause the video. You guys can pause too. I'll write down the answers and you can double check your work. All right, I am back. Here are your answers for factoring out the greatest common factor. And hopefully that went okay for you guys. One thing I do want you to notice here, I factored out a negative 4x to the 4th just so that I could make the value of this leading coefficient inside my parentheses positive. That will help us with continuing to factor. If you did not do that, another way you could have expressed this answer is you could have left the negative inside the parentheses, and I think that and that would be a fine answer as well. It's not wrong, I just think it's going to be better for us if we go ahead and factor that negative 1 and get that leading value to be positive. For what we're going to do next. All right, so we've tackled greatest common factor. Now what we're going to tackle is working through some of these factoring trinomials. And if you haven't already gone through the practice with the work that we did with a baseball diamond, I'm going to go ahead and make sure that everyone gets a chance to practice with that. But let me kind of give you sort of the gist of what that looked like. Okay, so we were practicing with this scenario where we had sort of a baseball diamond, right? Kind of set like this. And over here in the top, like at second base, we had a number like, I don't know, 15, let's say. And down here on the bottom, we had the number 8. Okay, this is just an example. And what we were practicing kind of over and over again with positive and negative integers is figuring out how we can get two numbers to multiply to be this top value, and how we could get them to add, those same two numbers to add to be this bottom value. So if you haven't had that opportunity to practice yet, don't worry, you will. We'll make sure that that happens. But the goal here is to kind of think about your factors of 15 and how we can make them multiply to be 15, but then add to be 8. So one of the things you can try is to think of, first of all your multiples of 15, like 1 times 15 is 15, right? 3 times 5 is 15. And as you look at these two options, there's only one of them that when you add the two numbers, right, we're looking at multiples first. So we're like, okay, these multiply, that's checked off my list. But 15 plus 1 is 16, so that doesn't add up to 8, but 3 plus 5 does, right? So when you add 3 and 5 together, you get 8. So that means that we can use 3 and 5 to solve that puzzle, essentially. Okay? So again, you'll get some practice with that. Now, what I like to do with our factoring is kind of start out with the puzzle in the same way. And I'm just going to make this X part so I don't have to draw the whole baseball diamond. So I'm going to make kind of this X as an organizational tool. Some people do this differently, but whatever works for you is great. And we are going to multiply the last number by the leading coefficient. In this case, and in the case of each of the questions that I'm doing in this video, we're just starting with the standard form of a quadratic. So we're looking at a polynomial that has this form, ax squared plus bx plus c. And what we're going to do is we're first going to identify your value of a, your value of b, and your value of c. So in this case, a is equal to 1, b is equal to 11, and c is equal to 30. Okay? And we are going to put whatever is our a value times whatever is our c value in this second base spot. Okay, so 1 times 30 is 30. Perfect. And we're going to grab our b value and we're going to put it in this home plate spot right there. So that's going to be an 11. And then again, you're going to ask yourself, how do I get two numbers to multiply to be the top, multiply to be 30, essentially this number right here, and add together to be my middle term, which is this number right here. And maybe you guys are kind of brainstorming multiples of 30. 1 times 30, oh, that's going to be 31. 2 times 15, that makes 30, but oh, yeah, when we add those together, that's 17. That's not going to work. What about 3 times 10? 3 times 10 is 30. 3 plus 10? Oh, yep, see, we're still trying to get to 11. So, oh, what about 5 and 6? There it is. The numbers 5 and 6. Okay, so we have this process, and for when a is equal to 1, we can actually use 5 and 6 in our two binomials that are going to be the factored form of our original binomial. Now that's a little bit of a shortcut, okay? I do want to show you how you can use the area model that we've been working on to work through these problems as well. Okay, so because we have just a little bit of time and because this is a recorded video, we may need to discuss how we see this coming about as kind of the opposite or working in the reverse direction as when you multiply two binomials to get a trinomial. And here I'm throwing a lot of big words out at you. Sorry, guys. Okay, so I want to show you, let's go ahead and do number 8. And I'm going to give us a little, I'm going to reduce the size on this a little bit so you can kind of give us a little extra room over here. Okay. Let's get rid of that. Okay, so we're going to do the same thing. We're going to build our kind of our baseball diamond here, right? We're going to identify our values of A, B, and C. So in this case, A is equal to 1, B is equal to 7. Ooh, this is going to be a little trickier. C is equal to a negative 30. Okay, so remember A times C goes in the top, so this is going to be a negative 30 in the top. It's going to be a 7 in the bottom, and so you have to ask yourself, what are two numbers that multiply to be a negative 30? So I'm going to need one positive and one negative in order for my outcome to be negative. And when I add them together, I'm going to get 7. Okay. You can pause and think about this if you'd like, and then come back. I'm just going to keep rolling. All right. So I'm thinking 10 and 3 somehow. 10 and 3, 10 and 3. So if I use, let's see, if I use a negative 10 and a positive 3, will that work? When I add those together, nope, that would make a negative 7. I want a positive 7. So let's change that up just a little bit, because that worked for getting a negative 30. Let's, instead of doing the negative 10, let's do a negative 3 and a positive 10. Let's see, will that work? What do we got? We got negative 3 plus 10 is positive 7, so that works, and negative 3 times 10 is negative 30. Awesome, okay. So what we're going to do is I want to show you how you can continue to use a negative 3x and a 10x as a replacement for a positive 7x as we build our factoring box right here. Okay. So this strategy is going to help a lot when A is not equal to 1, but I want to show it to you here and now first. So here we go. So what I'm going to do is I'm going to go ahead and I'm going to take this x squared, that first term, whether it's a 2x squared or 3x squared, whatever it happens to be, and I'm going to put it in the top left-hand corner. Then I'm going to take my 7x, this term right here, and I'm going to divide it evenly between two boxes, not evenly between two boxes, but I'm going to divide it according to our rule that we found of using a negative 3 combined with a positive 10 to get our positive 7x. And then for my very last box, I'm going to throw a little negative 30 in there. Okay. And here we go. Remember how we were looking for greatest common factors? We're going to just do that again. Let's try it. We're going to go up through these two boxes, and it looks like both of these are divisible by 10, right? 3 times 10 is 30, and I have a 10 right there, so it looks like I have 10 coming out of those two boxes. What's common between these two boxes? Just an x. How about if I go over? So I'm going to change this up. Got a lot of different colors going on here, but these are the two boxes I'm looking at now. Negative 3x and negative 30. Well, I think that's going to be a negative 3. That one's going to be pretty straightforward. That's common to both of those. And then I also want to go through these two boxes right here. And let's see, what is shared between those two? Looks like just an x. Well, that's it. You have worked backwards to factor a trinomial. We have been multiplying these together. We've done a lot of practice with doing things like x plus 10 times x minus 3. Well, now you're taking the answer and working backwards to find those factors. Okay? So that's the goal of this work. That's the goal of this video. I'm going to go ahead and do 9 and 10 real quick, but I'm just going to show you the answers. So I will go through the process of what I did. So if you want to try them first, that would be a really great way to practice. And then in the next video, we're going to go on to some special cases and also talk about what happens if a is not equal to 1. Okay, but that'll be in the next video. So try 9 and 10, come back in like 2 shakes and see if you got your answers right. Okay, that was pretty magic. If you just kept the video rolling, all of those answers in that work just poof, just appeared. Couple things to just note. This one just had everything positive on number 9. So my final answer was x plus 2 times the quantity x plus 10. And on this problem over here, sometimes things get a little tricky when we start working with negatives. So remember that in order to get a positive value here of 24 and have 2 numbers that add up to be a negative 11, these 2 values had to be negative. So a negative times a negative was our positive 24. But if I've, lost 8 bananas and I lose 3 more, I've lost 11 bananas altogether, right? So my negative 8 minus 3 more is going to be my negative 11. I built my area model and factored, and the correct answer here was r minus 3 times the quantity r minus 8. So hopefully that went well for you guys. We'll just keep practicing. I know it is a challenging concept. Don't worry, we'll get it. All right, take care of you.